Now in the videos he talked a little bit about non-Euclidean geometry and some different things that we see with that. An upper level math class, like junior, senior level math class, you could take a non-Euclidean geometry and be prepared for your mind to be blown in certain ways. I'll kind of introduce you to a few more kind of topics. We won't go into great detail on this, but one of the main problems with geometry, as we have called it up to this point, is the idea of parallel lines. How would you define parallel lines? Okay, parallel lines, probably the best definition or the most commonly thought of is two lines that do not intersect. Now, in geometry class, we've always thought our system or our I can't think of a good word for it, but we look at the plane, an infinite plane, as our basis. Infinite plane. So two lines that do not intersect, parallel lines, we would consider something like that. Well, if I could draw straight. Sometimes if I'm drawing something, you have to use your imagination that it is the way it's supposed to be, not the way I draw it. But I show many examples of why I'm not an art teacher. But two parallel lines, two lines that do not intersect, this would be one way we'd define it in plane geometry. What we have to say, plane geometry. Now, let's take a look at another system. If we think of our world as just this circle, and we use the same definition that we used earlier for parallel lines, we could create two parallel lines that look differently than we expect. We said any two lines that do not intersect, well, we could choose that as one line in our system, and that would be another line in our system that does not intersect with the first one. So by that definition, these would be parallel lines. They sure don't look like parallel lines with what our minds are programmed for, but by that definition, those two would be parallel lines. Okay? Questions there? Good question. Should we use that definition? Well, this is why in mathematics, and especially in geometry, we have to be extremely detailed in the way we use the definition. So this is one thing that as you go beyond what we study here, like I said, maybe a junior or senior level math class in college, you'll get into these ideas and having to really be very specific, very detailed in the definitions that we use. Okay? This would be one example of kind of going beyond what we consider Euclidean geometry or planar geometry, something that kind of falls apart when we look at a different system than just an infinite plane. Now, another illustration he used in the videos was a globe, and I'm not sure I'll be able to draw three-dimensional, but I'll try to hand draw. Oops, get back to. If we think about the globe and a sphere, basically a ball, if this is our system, then what are parallel lines? Well, he defined great lines, or what's the other term he used? I can't remember what the other term, but great lines where they would go through the poles, and or great circles is what he called it. They would go through the poles and have the center of the sphere as the center of that circle, like the equator. Okay. Well, how do we define parallel lines here? Okay. Well, one way in non-Euclidean geometry, if they would go through the poles, the North Pole and the South Pole, or like that, those, not the equator, but this one, and this one, all three of those would be considered as parallel lines within this system. They intersect, but they intersect up here at the North Pole and the South Pole. But through that definition, these, on a globe, we would call those the longitudinal lines. Okay. Those would be considered as parallel lines within that system. So non-Euclidean geometry, when we get away from looking at just the plane, just the infinite plane, it opens up some really, well, I guess you could call it crazy notions, and we can see very detailed definitions would need to be put together to be able to define what we're talking about for these systems.